Assalamualaikum. My name is Muhammad Akhil Shaidi bin Ahmad Nizam, and I will talk about topology optimization. So, what is topology optimization? Topology optimization is a procedure that optimizes the layout of material and the structure for a specific set of user rules inside a given 3D geometric design space. The aim is to maximize the system performance by model and optimizing external pressure, boundary conditions, and restriction analytically. The optimization of conventional topology uses the finite element method to assess design performance against given criteria. Despite its wide application range in engineering product design, optimization in topology is now mostly employed in the design phase to optimize size and form. Next is how topology optimization works. Finite element is the most popular and effective method for optimizing topology. Finite element refers to a method of design which depends on simulation for determining which portions of an object are not structurally critical and therefore can be deleted. The initial step toward the finite element-based topology optimization is the identification of load, features, limitation, and design space. In order to provide a range of design possibilities and guide the designer to the best feasible design, the software will then examine the specific constraint. The software repeats the procedure to improve the geometry after a design is chosen. Next is advantages of topology optimization. There are three, which is shortened design process, better performance, and cost efficiency. For shortened design process, optimization of topology can significantly reduce the time frame for product development, which leads to lower cost. The automated methodology often leads to superior performance component in far less time than traditional design method will require. Meanwhile, for better performance, the ideal design for a specific part is not always intuitive, and without the assistance of computer, it might never have been developed by the design team. For the cost efficiency, optimizing topology reduces unneeded characteristics or materials, saving waste and expenses. Moreover, they tend to lower the energy consumption in their final application because the components are lighter.
Railway bearing plate. Bearing plate of railway are cast iron, wrought iron and mixed steel plate that are inserted between the FF rail. Bearing plates are installed under FF rail to alleviate the problem and keep the pressure intensity under control. In this study, a bearing plate considers a case study model to study the potential of topology optimized design approach in reducing the weight of railway blade that can be produced using additive manufacturing, 3D printing. Before doing topology optimization process, the mass of bearing plate that we use is 30.504 kg. After doing topology optimization process, the mass of the plate is slightly different than before and become the better design of it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akhil, and today I will present about the chapter 2, which is methodology. Okay, without wasting time, let's get started. Introduction. This methodology section will cover the entire process of studying the topology optimization. The model will be designed using the ANSYS space claim. And then the model will go through the topology optimization using the ANSYS workbench. After being optimized, the design will be redesigned using the same software, which is ANSYS space claim, and it will go through the same process again, so we can compare the result, which is maximum equivalent, one missile stress, total deformation, and safety factor. Okay, next, which is a CAE, which is a computer aided design. Computer aided design, or CAD, involved in using computer to help with engineering and design for a wide range of projects in various industries. Metal fabrication, carpentry, and 3D printing are some common applications that are available in manufacturing. In our project, which is we using the ANSYS workbench, which is a platform, is the ANSYS workbench platform is the backbone for delivering a comprehensive and integrated simulation. It is used to perform a various types of structural, thermal, fluid, and electromagnetic analysis. Next is topology optimization. Topology optimization has been used by mechanical and civil engineers for many years. In order to minimize the amount of used material and the strain, energy of structure while maintaining their mechanical strength. Topology optimization is a mathematical method which is specially optimizes the distribution of material within a defined domain by fulfilling given a constraint previous established and minimizing a predefined cost function. There are three elements in the topology optimization, which is the design variable, the cost function, and the constraint. Okay, next we talk about the the method that we use when we use the ANSYS. First, we select the static structural, and then we select the material. Before we measure it, select the material before we measure it. After that, after measuring the material, we have to determine the support for the model. Okay, for the left, which is the support for the model, which is the cylindrical support, and the right is the force that we have to apply onto the model. Okay, next, after we determine the force and the support for the model, we have to select the topology optimization in the analysis system and bind with the statical and the static structure function. Okay, next, after we after we select the topology automation and bind with the static structure, we have to run the topology optimization analysis on our model with the constraint analysis for the 60%, and this is the result that we got after we run the topology automation. Next, after we redone the topology automation, we must have the redesign our model to the new model, which is from the left is the surface before the redesign, and the right is the surface of model after redesign. After redesign, so this is the model we have to create after the redesign, and the left is the before and the right is the after. Okay, that's all for me. Thank you.
Hello, my name is Jeremiah Camillus, and now I'm going to present to you the results of our project. So based from this, we can see that the original rail bearing plate design, the maximum equivalent bond measure stress obtained was 1.0556 times 10 to the power 8 Pascal, and minimum equivalent bond measure stress is 6,537.1 Pascal after being loaded with 50,000 Newton of load. Next, we see the total deformation, which we obtained was the maximum is 2.0581 times 10 to the power of negative 5 meter. And next is the safety factor, where the minimum safety factor that we obtained for the original rail bearing plate design was 2.3683. And the mass of the original rail bearing plate design was 13.504 kg. And this is the topology optimization results that was done on the rail bearing plate design. And on the left side, we can see that the design is not really good, and it was hard to be manufactured, so a redesign was done based on the topology optimization design, and we obtained it on the right side, which the mass is 8.4196 kg. And for the optimized rail bearing design plate, the minimum equivalent volume stress that we obtained was 2363.2 Pascal, and the maximum was 1.179 times 10 to the power of 8 Pascal. And the total deformation that we obtained is a maximum of 3.3289 times 10 to the power of negative 5 meter, and a safety factor of a minimum which is 2.1204. And this is the results comparison. From this table we can see that the maximum stress after optimized was increasing slightly when compared to the before optimized. The same goes for the total deformation, where we can see a slight increase. And for the minimum safety factor, there was a slight decrease after the optimization was done, but the safety factor that was obtained after optimized was still in the safe range. And from the mass we can see that there is a 62.35% of reduction of weight. And that's all from me. Thank you.
In conclusion, in terms of weight, strength, painting time, and design variability, comparisons are done between the original design and optimized design. The weight of the rail bearing plate has been reduced from 13.504 kg to 8.4196 kg. This is almost 62.35% weight reduction from its original weight.